potentiation. Okay, LTP, long-term potentiation at the hippocampal neurons. Hippocampal neurons, particularly in the CA1 region, there will be long-term potentiation. Okay, and here we are talking about the postsynaptic neurons. See, cortex is projecting on the hippocampus. This is a presynaptic neuron. There will be a postsynaptic neuron which will get modified. Okay, so please remember, all the events of learning and memory are basically presynaptic events except this one, long-term potentiation or long-term memory. Neurotransmitter involved is what? Of course, it is the glutamate. It is an excitatory transmission, so it is glutamate, no doubt. And glutamate has various receptors. We did that in the neurotransmitter section. But here the receptor involved is NMDA receptor, N-methyl D-aspartate receptor. So presynaptic neuron coming from the cortex, ending on the hippocampal neuron, it will release glutamate. And on the postsynaptic membrane in the hippocampus, there is NMDA receptor. So see, NMDA receptor has calcium channel associated with it. What happens is that glutamate is released by the presynaptic neuron. It binds with its NMDA receptor in the postsynaptic membrane. Now, there is opening of calcium channels in the postsynaptic membrane. Calcium influx happens, and this calcium influx causes long-term excitations, long-term potentiation, meaning that this postsynaptic neuron is now potentiated. That means impulse coming from any other neuron, and this neuron will immediately respond. It will immediately fire, even with a low threshold. And that means you can recall that event even after a few years. It is stored in this particular synapse. Okay, so long-term potentiation of the postsynaptic neuron. It has been potentiated means what? Response by this postsynaptic neuron is exaggerated. So every time, what is meaning of exaggeration or potentiated? Every time you try to recall a certain event in the past, 5 years ago event, it is in this particular synapse, and you try to just recall it by some neuron sending signal to this neuron, there will be immediate response by this neuron, and immediate response means you recall that event even after 5 years. So that is long-term potentiation of the postsynaptic neuron in the hippocampus. So that's the basis for long-term memory. Also, please understand that there are structural changes involved in the long-term memory. See, so far learning, then other types of memory, there were no structural changes. It was only increased release of neurotransmitter, decreased release of neurotransmitter, something like that. In the case of long-term memory, there will be structural changes. Means what? New synaptic contacts get developed. How does this happen? There will be changes in the dendritic geometry. There will be changes in the dendritic geometry. So, what will happen is, let's say this is the postsynaptic neuron involved in the long-term memory. This is where it is stored. The other neuron will come, its dendritic geometry will change for the other neuron, and it will make a synaptic contact with this neuron and will try to recall the event even after 5 years, even after 10 years. So, that's because the geometry of this neuron changed and it made contact with this neuron to recall the information every time. you try to recall it, okay, on a long-term basis. This neuron is already potentiated by the NMDA receptor. So that is how there is structural change happening. Or, well, I hope you have understood structural change. It is in this dendritic geometry change for this particular neuron. Next, increased neurotransmitter synthesis, increased release sites for the neurotransmitter. These are all the structural changes. So remember, the only event in which structural changes happen in the brain is the long-term memory. Otherwise, learning and memory will not involve structural changes, except this one, okay.